So now let's go through a little piece of code that just shows how some of these EEPROM library functions, namely read and write, could be used in practice. This is a very simple piece of code, but we'll walk through it just to see how the functions are called. So in this example, this simple sketch, all we've got is a setup. I'm not showing the loop, but presumably the loop wouldn't contain anything. I just want to show the setup right now. So in my setup, I'll say, okay, so I'll start off defining an integer for the address. Then we got serial begin. Now the reason why I do serial.begin is because I'm going to write some stuff to the serial monitor. So I start serial.begin. But then there's a for loop. There are two for loops, actually. So you see two for loops. The top one is basically writing to the EEPROM. And the bottom one is reading from the EEPROM. So if you look at the top one, we're going from the addresses from, if you look at it, starts with address equals 0 to address equals 10, is less than 1024. So it's going to go from 0 to 1023, which is the size of the EEPROM, because we want to write to every address in the EEPROM. Then we call EEPROM.write and give it an address, comma, address. Notice those are both arguments are address. So what I'm doing here is the first argument is the actual address that I want to write to. The second argument is the data that I want to write to that address. So in this case, the data that I'm writing to the address is actually the address itself. So I'm writing a 0 to address 0, a 1 to address 1, and so on. So that's all that loop does. It writes the whole EEPROM and writes numbers to every value, every location in there. So then the second loop is just going through every address again, same range of addresses, 0 to 1024. 0 to 1023 really, because its address is less than 1024. And it's doing a print, a serial print. And in that print, it's calling EEPROM.read. So it goes to the address, reads the contents of the address, and just prints it to the serial monitor. Now note that serial.print, it takes that second argument, DEC, that just stands for decimal, to tell it to interpret the data, the byte that it gets. It says, when you're printing this, interpret it as a decimal number, just so we see it as a decimal number on the serial monitor. But that's it. This is pretty straightforward, you know. And now this program is incomplete. It's not including the hashtag include that you have to have at the top. So whenever you use one of these libraries, you want to include the library, right? So there will be .header files, .h files, which are called header files for every library. So in this case, I believe it's called EEPROM.h. So you have to say hashtag include EEPROM.h at the top. Or you can do that through the IDE as well. But either way, that would be in there. Also, there'd be a loop in here, which maybe would be empty. Right? So I've omitted those just for simplicity, but this just gives you a little example of how you would use these functions. Okay, so now let's say you want to access multiple bytes in the EEPROM. So right now, so the way the EEPROM works is this one address, one byte. But there are numbers that are bigger than 1 byte. So for instance, in the Mega 328 that we're working with, an integer is 2 bytes long, right? So say you want to take this 2 byte number and store it in an address. Or really, so first thing to remember is that you can't store it in one address. You have to store it in 2 addresses, right? It's 2 bytes, it takes 2 addresses. So you can generally only read-write one at a time. Say you want to do multiple. You want to deal with ints, which are 2 bytes long. So the common way to do this is to use masking to access a single byte at a time. So take an integer. You've got a 2 byte number. You want to be able to, say you want to write this to memory. You want to write the first byte, write 1 byte, then write the next byte. Okay? So when you write the 1 byte, you want to ignore the other byte. So it's a 2 byte number. One is the most significant byte, one is the least significant byte. When you're writing the least significant byte, you need to ignore the most significant byte. When you're writing the most significant byte, you need to ignore the least significant byte. So masking is just a way of ignoring bits inside a word. So if we look at an integer, it's going to be 16 bits long. If we want to focus on the low byte, the least significant 8 bits, we need to ignore the high bits. Okay? So masking is a way so that we can say, look, these are the bits we're interested in, and these other bits, ignore them. So a mask, when you're using masking, when you're performing masking, you need to use what's called a mask. A mask is a series of bits that highlights the bits in the number that we're interested in. So if you've got an integer, 16 bits, and we're interested in the high bits, the high 8 bits, then the mask is going to say, it's also going to be a 16-bit number. The high 8 bits will be 1s. Okay? And the low 8 bits will be 0s. And the bits that are 0s are the ones that we're going to ignore. The bits that are 1s, which will be the high 8 bits in our data, will be the ones that we're going to focus on. Okay? So that's what a mask is. It highlights the bits in the number that we're interested in. So the mask is a different number that has 1s in the bits that we're interested in, 0s in the bits that we're not. And then you perform what's called a bitwise AND operation. You take the data that you're looking at and you AND it, you perform a bitwise AND with the mask. And the bitwise AND, basically what that does is any masked bit that has a 1 in its bit position, that bit it doesn't change, but the bits that have zeros, they're zeroed out. They become 0 because that's how an AND operation works. So when you AND something with a 0, it becomes a 0. So what that does by doing this bitwise AND, it zeroes out all the bits that you're not interested in, but the bits that you are interested in keep their value. So that's the intuition. Thank you.